So no, my question about the
Hello and welcome to an exciting episode of Gotham Sound TV. Sorry for the delay. I think Zoom is acting a little funny for us, but we are here live with Ariel Rocholl, the creator of RF Explorer, zooming in from Spain. Say hello, Ariel.
Hello, everybody. Nice to be here.
Great to see you. We're also here with Chris Regan, CEO of RF Venue. Did I get your title right, Chris?
Former CEO. They kicked me out. I'm now Chief Innovation Officer, so leading product. Hugh Tripp is the current CEO of RF Venue.
Excellent. All right. Well, gentlemen, I am super glad to be here with you guys. We are here showing the RF Explorer Pro, brand new, out yesterday, I think. Is that right?
Yep.
That's right.
All right. So I think, first of all, everybody, I'm coming off of a cold. It's not, I don't have COVID, I don't have a fever, but I am slower and spacier than usual. So I really appreciate you guys coming through with any questions and comments and helping me out as best as possible. So, all right, here we go. Let's get into it. Tell me, what is the RF Explorer Pro? Like, what's the sort of brief synopsis that you can give of the history of RF Explorer, and then, what's new about the RF Explorer Pro? Chris, do you want to start?
I don't know. I think I'd kick that one over to Ariel, actually.
Fair enough, Ariel.
Kind of how he came into the product, etc.
And I think we have to say Ariel's the creator of the RF Explorer.
Yeah, we have been dealing with spectrum analysis diagnostic tools, as you know, Peter, very well, for more than a decade. And we have been collecting feedback from customers from certainly different industries and applications, being wireless audio certainly one of the most successful areas, business areas we are working with for a long time. Both your shop and certainly Chris as a company has been very helpful over the years to fine-tune our applications so it gets better and better for actually going to a venue and resolving problems. So for us, RF Explorer Pro is kind of the product we wanted to produce with capacity and capabilities to cover all possible scenarios. Most of them should be available already on the version you have on your hand, but some of them will be available in future upgrades. So for us, it's kind of the flagship product we want to provide as the one single device solution for all the wireless audio needs.
So most basic, it's a spectrum analyzer. It's an affordable spectrum analyzer. And for how can our customers are sound mixers on film and TV sets? Let's talk about how they can use a spectrum analyzer and what they would use it for.
Yeah, I can help address that one. So when I started working with Ariel and the RF Explorer team years ago in spectrum analysis, it came out of a huge need. The ability to visualize and monitor and manage what's going on with these RF systems can be the difference between success and failure. Whether you're doing location TV or arena tours, whatever the level of sort of application you're at, you need to understand what the environment is like that you're operating in. And there are a range of ways to do that. Something like Shore's wireless workbench, or any of the networked mic receivers now that can perform a scan. But none of them are as good and as thorough, I guess I would say, as a dedicated RF spectrum analysis device like the RF Explorer Pro. And I also discovered years ago that a huge part of the market is not really aware of this as a tool. I know that Gotham's customers tend to be definitely on the more advanced side of these projects, and so RF Venue has spent a lot of time trying to educate the market about these tools and what they can do, starting with desktop software that we developed for RF Explorer to cloud-based systems for RF Explorer. And I feel like this is sort of the evolution of a lot of those efforts in a way, to kind of bring it all together in a device that is, fast and accurate and does all the things it needs to do from a technical standpoint, but also very approachable. A lot of high-end spectrum analysis tools, we have them in our lab for product development. They're amazing. They can weigh 20, 30, 40 pounds and cost anywhere from $8,000 to $40,000, depending on, how many decimal places you want to take the test measurement system out to. And so those are not practical for the vast majority of people working in wireless audio. So this, I think, is the first product that I've ever seen that has the intuitive nature of a tablet, the sort of the engine of a high-end spectrum analyzer, packaged in a way that is easy to use and carry around, super portable. So that's kind of the underlying sort of job to be done for this thing in wireless audio is helping you visualize and monitor what's going on. And then I would say the second item would be the data capture, the ability to get the data you need to then take it somewhere else to do frequency coordination, whether that's Electrosonics gear or Shore gear or Sennheiser, whatever it is. That is something that we're going to need, as users of these systems to do periodically as the spectrum changes, because it's dynamic by nature. So those are kind of the two main things I would say. The production sound community could definitely get out of it.
So let's get into it, because the RF Explorer Pro really is the next generation. Jared, I'm just going to show this to the overhead. You're already there. So this is what we're looking at. It is a tablet. It's a Windows tablet under the hood, and we'll get into that. It has a series of SMA connectors on the top, one of which is RF in, and we'll talk briefly about the others, depending on how much time we may really get into some detail. And there's a USB-C for power on the side here, HDMI, which is how we're feeding. Jared, if you just want to show the clean feed of the spectrum analysis, yeah, there it is. That's how we're feeding that. And then a USB, which is a USB-A, and it's going actually to a hub. And the hub is connected to an Ethernet dongle. And I think right away I'm going to talk about the Ethernet dongle because I think it's so cool. Because it's a Windows operating system embedded under the hood, Ethernet, it's got an Ethernet driver, and it's got VNC. So, this showed up essentially yesterday. It is very intuitive, but I didn't feel comfortable driving this on a live stream. And so Ariel said, well, I can VNC into it. And so I would say, that's kind of an amazing feature right out the gate. So Ariel, take us through some of the features. Oh, I think you might be muted.
I'm muted, sorry.
No.
I'm glad to. So, as you said, this is basically a spectrum analyzer around which we built a number of additional features that you wouldn't find in a spectrum analyzer. Everything is on the mode menu. Let me go into it. So the mode menu has
I
everything you
just want to
have
pause. I'm
available.
sorry, Ariel. I just want to pause for a second and just say, how cool is it that you're controlling this from Spain? And I just have to point that out. Anyway, Spectrum Analyzer. Sorry to interrupt. Go.
Yes, I'm actually also happy that works seamlessly. As you know, BNC is a free, very long-term tool used worldwide for all sort of remote connections. So we are pretty certain you can remote from anywhere, even your cell phone, any brand of cell phone, tablet, or any device that has Ethernet connection can do with it. And with a fast connection, you can actually see a real-time screen, which is also nice because some of the diagnostics you might run, you might help to resolve remotely on a venue or on a or in a setup, might need to actually see fast screen as you do changes. So this is kind of basic capabilities. Now, Spectrum Analyzer, which we are looking at, is the first mode. We have power channel, Wi-Fi analyzer, different view as waterfalls. We can do tracking because there's a generator embedded that works as a tracking generator. We can do power meter, which is also a very nice feature to look into 8 gigahertz instantaneous radiation. You don't see where specifically on the spectrum is, but you can have a very quick view of how strong a radiation can be, regardless the frequency. That's instantaneous. You can do zero span, which is probably not very useful for audio wireless setups. And you can, of course, have frequency coordination mode that might be the most useful mode for your users. So spectrum analyzer mode, you have frequency amplitude control. You can, of course, specify that manually, like let me change the center frequency, for instance, to, let's say, 800 megahertz.
By the way,
and move the span.
we should just while you're talking about Ariel, just while you're talking about frequency, what is the frequency span of the RF Explorer Pro?
You mean the maximum frequency span?
Yes.
6 gigahertz. So with this, you can change numerically as in any spectrum analyzer. But if you can help me out here, Peter, you can do some touch screen gestures as well to do the same, to achieve the same goal, right?
Absolutely. So I'll change the start and stop if that's all right. So here, for UHF, let's say I'm interested in 470 megahertz, and the stop I can make at let's just say arbitrarily clear 636 megahertz. And yeah, and it's that easy. So now that I have that on my scan, and tell me about the view that we're looking at. This is a live view, or is this is max hold? What are we looking at, and can we change that?
Yes, this is real time, and you can go back and go to the config menu to display additional graphs like max hold, average, etc. So let me go back and go to the config menu where a lot of configuration details can be adjusted for your device. And then let's put a max hold view and have it field trace. So you have accumulated maximum capture of your spectrum, and you can change any number of reasonable things like colors or having the grid or not. And let's put max peak, which will peak over the last 100 sweeps automatically. So it's more dynamic than a max hold. So in addition to that, as I said before, you can use touch gestures to increase or decrease the span, move the amplitude,
So I
back
will.
and forth, etc.
I'll show that. So I think I can zoom in or zoom out. And Jared, I think if you want to go to the overhead, yeah, there we go. I'm just sort of pinching to achieve that, which is great.
You can also manipulate the signal level by pulling up and pulling down, which is kind of handy if you have a really quiet noise floor or high noise floor or whatever.
So there we go. So yeah, and you can kind of see it here. I'll kind of tilt up a little bit.
So as you would expect on a touch screen device, you can do a number of things simpler, although they might not be as accurate as you do with the numerical keypad.
Mm-hmm. I know we're skipping around a little bit, but there's one feature that absolutely blew my mind as we were kind of going through it yesterday in our rehearsal. The time machine. I call it the time machine. I don't know what you call it, but can you show us that?
Yeah, we can call it Moviola if you want, but it's basically a historical in RAM, so it's memory real-time capture that you can go back to any event since you started capturing. So you can move around any specific incident that might be passed a few seconds ago or minutes ago. And you can even replay with the capture speed from that point on anytime. So as opposed to some other instruments that would capture some activity, you don't need to start recording anything. It's all the time recording, and you can, of course, persist this to a file to later review or sharing with someone else, or just keep it in RAM by default. You can freeze the screen anytime and start playing again, or go live with a real-time signal very easily. So everything is touch in that regard, but it's very powerful in our perspective to be able to go back very quickly and review what happened a few minutes ago.
All right, and for anybody watching, I will see the comments and I will ask Ariel and Chris. So please feel free to put your questions and your comments in the comments, and I will relay them. This is, yeah, I mean, that alone is amazing. So let's say I have my, I've done my scan at my location. How do I save it?
So you can save two different ways. Basically, one will be the standard CSV file. For that, you go to the file menu, click CSV, and if you have a USB dongle, it will automatically go to that specific location, and the file will be ready to be extracted and shared with your computer. If you don't, then it will be saved in internal memory, as you can see here. Mm-hmm. You can change the name, etc. So this will be our CSV file that is a snapshot of the exact spectrum that was at that particular time. But you can save in a binary format, which is an accumulative spectrum with all the history that has been captured. So you can replay later anytime all the sequence, not only the snapshot that is in the CSV. And after loading this binary file, you can re-export any point to a CSV file again.
And that's using desktop software that's available for download. Is there a cost for that desktop software?
That's free download, and you can convert and actually load any file. So we can load these files actually on the tablet itself and convert to a CSV, but you can do in a computer as well.
And if so, just as the time machine function, the historical data, that I can see being so useful in a real-time situation. If a radio mic takes a hit, and that way you can say, what was that? And then go back in time and see if it was an RF hit. And if you can see it, great, there's your answer. If you can't see it, then you know maybe you need to look elsewhere. But it's so helpful to have, and to at least with the spectrum analyzers that I use, which are Enritsu and TTI, unique among spectrum analysis hardware.
We think so. Even desktop lab grade spectrum analyzer we have very expensive. They need you to buy a 3,000-4,000 software key, and that will still save from the point you start recording, and needs very fast network connection, etc. So it's kind of designed from scratch, because one of the feedbacks I mentioned from customers for a long time is we need to record from the, with a standalone device and then be able to review it later. That's basic for many diagnoses to improve in future venues or try to find the root cause of a problem. So we build this from scratch, and as you can see, it's reasonably fast to capture any standard RF event. Of course, this might not be able to catch a radar pulse, but for most of interference you can get in a venue, this should capture very easily.
We have our first question with Eric Lamontagne. I'm sorry if I butchered your name, Eric. Such a useful tool to have on any production set or other RF environment. Great evolution. Can the RF dynamic intensity range be adjusted? Would be handy for when we use 10 milliwatt versus 10 milliwatt transmitters.
From dynamic, I would expect that means if the instrument can adjust to stronger or significantly weaker signals. The instrument has about 100 dB dynamic range, which is a lot, and using antennas, this is reasonably protected against any strong signal. But of course, you can go to the config and device menu and select 3 different options with additional attenuation for very strong signals. And for very weak signals, you can use included preamplifier that also is included and don't need any additional license like other instruments. With this, you can get 25 dBs of additional sensitivity when signals are really weak, or you can be protected against signals as strong as 2 or 3 watts, which for an antenna capture instrument is about kilowatts of transmitted signal. So we think this can survive and provide meaningful readings on pretty much any environment.
Absolutely. Okay, so if that's all it did, I feel like, I don't know if you're familiar with the Ginsu steak knives commercials. If that's all it did, sorry, Ariel. If that's all it did, it'd be a hell of a bargain. But there's more. But wait, there's more. So
can I, Peter,
yes,
can I
absolutely,
comment on one thing?
Absolutely.
With the data capture, because that was something that also really got my attention, is how this device is managing a staggering number of data points. So like when you're recording spectrum or you're capturing spectrum data, you're primarily looking at 2 things, right? Frequency and amplitude. Now, take the step size of each individual step, the resolution bandwidth, and let's marry that up with 25 kilohertz, right? So a typical channel spacing on a UHF wireless microphone. Now, do the math on how many steps there are in 25 kilohertz increments between 470 and 636 megahertz. It's a ton.
Right.
And each sweep is capturing all that data, and it's being stacked in a replayable format. That is not trivial to do. And when you try to do that on a laptop, I mean, you could basically melt down your CPU depending on how granular you try to get. So I just think it's important to highlight that that's a really important capability to be able to go back and look. But then I've also found in using this, getting good at jumping between configuration settings where we want to look at a max hold. Okay, now let's look at an average hold. What are the most fixed frequencies there are, right? They're your DTV stations and other transmitters that aren't going anywhere. And let's look at the average versus the max hold, which is everything that comes through the sensor, right? And what you'll find is you can see those intermittent sources showing up in the max that will not show up in the average, that may or may not be present while you're looking at the real time spectrum. So I've found it's worth spending a little time in the configuration part of this, tweaking the colors, kind of getting the setup the way you like it. You can really kind of personalize it quite a bit, which is not something that a lot of other tools allow you to do. It's, this is a test measurement device, sort of a soulless, tool, whereas this is highly configurable, and you can interface it with all kinds of ways. Just taking a USB-A thumb drive and sticking it in the side, you can save a CSV file in less than 10 seconds. So I know a lot of location sound. We don't have the luxury of internet or connectivity. This is still highly capable in an offline use.
Yeah, I mean, look, if we want to show that, here's a USB thumb drive, and let me see. I've rigged this to be neat, and now, of course, I'm cursing myself. But here at the very edge is our USB hub. I plug in the thumb drive, and now let me see if I can figure this out. So if I go to, where would I go to save this, Ariel?
File.
Oh, geez. I'm going to blame that on my cold file, because it really couldn't have been more obvious. Copy to USB. Oh, well, okay. And I kind of like sort of figuring this out in real time. Save CSV. Now, one thing that's interesting is for very observant people, they'll notice before I put the USB thumb drive, it was the C drive. Now it's automatically saving it to the D drive. It's found my thumb drive, and so all I have to do is click save, and it's automatically saved to the thumb drive, and I'm done. And of course, you don't have to use a USB hub. We're just using it to get Ethernet going. So yeah, like Chris said, you'd stick the thumb drive in the side of it, and it'd be a much neater operation.
There's another way to get the scan data off the device, which I found super interesting. A couple of people asked about the capability, and I was talking to Ariel about it. With the VNC viewer, with I think it's called Tight VNC, is sort of the most native VNC application that will interface with the device. You can set up file transfers over the network that way. So you can have the file sitting on the remote VNC window and pull it off to your local machine. There is a way to do that. That has come up a couple times.
Yeah.
But what I'm really enjoying about this whole VNC thing, because I'm just an absolute rookie in terms of all things networking, and so I knew when I went to set it up, I was up and running in a matter of minutes, which is like never happened before. So it's very plug and play on that front.
Yep.
And the VNCs are free.
Yeah.
And you just download it to your phone. You're looking at and controlling the spectrum analyzer on your iPhone. It's like magic. It's pretty cool. And there's no drivers. There's no subscriptions. There's no apps. There's no, Apple yelling at you for installing a non-app store app. All those headaches are magically gone.
I used BVNC for what it's worth on my Mac, and it was instantaneous. I mean, it was probably the fastest thing I've ever tried to do. That's slightly out of the ordinary. So good. We're getting questions, and their questions are asking about stuff we're about to cover, which is even better. And so, yeah, first question, hello, good night from Malaysia. I'd love to hear our venue of new products. I shoot reality shows with a lot of transmitters and sometimes around 28. So my question is, how can this tool help me coordinate the frequency? And how familiar and friendly is it because I shoot around Asia? Before we get to that, a question just came in. Great product. Is there a way to export an average of multiple sweeps to a CSV? And I I think since we're talking about CSV, let's start with that one.
So you basically configure what the CSV behavior you want to be with a number of options. So for instance, we were selecting the max peak when saving the previous CSV. You can select real-time, average, etc. And you can select also, because depending on the tool you are going to import this file into, sometimes need separator to be different, or for instance, Sennheiser is kind of different format than the rest. So all that number of options is included based on our long experience exporting CSV files compatible to pretty much every tool. And in addition to that, when you are displaying information on a screen, you can select, of course, which screens you want to be. And normally you should be looking at the display you want to export. Otherwise, you might get surprising information, right? So if you want to display real-time or average, I would suggest first to make sure that you have the right screen selected and you are saving what you want. In addition, there's an option to automatically save CSV files. So depending on how you configure all these tools, you can get it every time you get something changing in your configuration being automatically saved to a file. So pretty much everything you might need to CSV should be included in the tool already.
Amazing. Adam Block has a long comment that I'm going to parse for us. I've been wanting a standalone bag cart-friendly real-time RF analysis display for quite some time, and the RF Explorer Pro looks like it will fill that need nicely. It needs to provide additional information on screen for it to be truly what he wants. One, can the graph hide or gray out frequencies that are illegal or otherwise unavailable for use? The software-based solution I currently use handles this via exclusion, which, again, Ariel, I know this is perfect because this is where we're going. Can the graph identify your transmitters? And three, can it identify which peaks are known sources, such as TV stations? So I think between that and between Noor's comment, let's get into frequency coordination.
Okay, so let me first clean up the screen a little bit. Mm-hmm. So we focus on the real-time graph only. And then, of course, I don't think we mentioned, but you can get a full screen anytime just by clicking on a screen once and then get the menu back.
Yep.
So you have data available at your convenience. And then going back to modes and jumping over a few of them, we can go directly to frequency coordination, which, as you said, Peter, before, we think is the first spectrum analyzer, including frequency coordination as part of the available functions online. You don't need any external tool to coordinate frequencies. The configuration and the workflow is kind of familiar from other commercial tools that do frequency coordination of computers. You first start a new project, which you can name anyone and provide description and certainly a file name that, as you pointed out, Peter, this will be saved to USB file. Mm-hmm. And then select the frequencies. I think you were using 632 or 642?
Well, I think if that's, 640 for the stop frequency. I mean, that's okay. higher than I typically go, but yeah.
And maybe 470, right?
Sure, yeah.
Okay, so this would be the frequency range I would expect to locate all my wireless devices. Answering one of the questions that you had online, you would set up any exclusion that you know is illegal or you don't want to deal with at all as one exclusion and select the frequency range
Well,
for that
actually,
exclusion.
so Ariel, in New York, I would do 470 to 488 as an exclusion for T-band.
Okay. For 88, you said?
Yeah, is that right? 470? Yeah, I think so.
Okay.
Yes.
And let's just, for the sake of visibility, add another one that will go to 520 to 530.
And we can name these, right? They don't have to live as exclusion 1, exclusion 2.
Right.
Mm-hmm.
Absolutely. So we save the project with any name we want. And we can reuse these projects, meaning after we set up a venue, the brands of the wireless devices, frequency ranges, if we are going to a venue that is close enough, you might open and reuse it and just change what's different.
And I'm just gonna make a correction while you talk, Ariel.
So basically, you can reuse any past project and start from there, or even save as a template. Thank you, Peter, for the correction.
Thank you.
Now, after we configure the basic project settings, the next thing will be to add devices to the inventory. The first time you open the inventory, because it's a large database of commercial devices, might take a few seconds. And it includes pretty much all the commercial devices from these brands. These brands, which are, I think, 8 at the moment, but this will be populated and increased with inputs from several sources, including RF Venue Nice online tool, which has a very updated database of brands and models. So,
and Ariel,
do you want?
Sorry, just to be clear, you only add your global inventory once. I mean, presumably you change it as your inventory changes, but you really only have to do this, go through this particular part of the process once.
I would say so. If you use your own device stock, you probably do this once. If you are maybe renting, I don't know. So this can adjust to any profile, but you would typically do this once. So do you want Peter to perhaps select what makes more sense for this band or these scenarios?
I'll do a couple of sure. And yeah, we'll do interesting. AD4Q. G57 plus, why not? And I'll do some electrosonics. By the way, while I'm futzing with this, Eric has a good question, which is, we know it goes up to 6 gigahertz, but how low does it go? Because sound devices can go as low as 168 megahertz.
You can go down all the way to 15 megahertz.
All right. So let's say we do tracking, and it's interesting. Yeah, I mean this is very very complete. What I don't see here, and maybe this will be part of an upgrade, is I don't see like A1 B1 blocks for electro. Is there someplace else I should look, or will that come as part of an upgrade?
No, it should be there. So it's not including that particular set of bands.
Okay. But I'll choose block 22 just for the time being.
Okay. In addition to that, if we don't have the specific model in our database, you can define customs, as pretty much every tool does, and select with a name something descriptive for the band, and then indicate here what's the start-stop frequencies for that. Let's say this is a valid setup for a model we don't currently have. This will be stored in local memory, so you can reuse that anytime from this point on. So in the meantime, we need to populate certain models that are not yet in the database, or a particular brand that is not included in our database. You should be able to do this. And again, this is needed to be only once.
Got it. Yep.
After we set that the global inventory, I mean, what brands and models I be using, then you create the specific instances of every specific microphone or a wireless device you need. So you will get one by default of each model. The tool assumes you want one of each, and you can add as many as you need and change from the available models that you selected on the inventory. So you can have as many as you need here, and you can add multiple in one go. And then select, which of these models is actually the one that is supposed to be added. And of course, you can name it more truthfully than the default name.
Got it. So you can name it with an actor's name or however you want to do that.
Yes,
and
absolutely.
Just a question about the models that you can sort of add, the custom models. That presumably just takes a kind of average profile of a typical analog radio mic. Is that fair to say? In terms of like what the characteristics of that generic custom model that you're adding?
Yes, you can select basically a start-stop frequency that should be valid for that particular band. And then the step in kilohertz that at the moment is 25 kilohertz default, but future versions might allow different steps if that's required. But we found that 25 kilohertz would answer for pretty much everyone.
Got it.
Now with this already configured, we have our project devices and models already in place. Seems the right time to look at how we can coordinate all these guys into the spectrum. So you have this threshold that will be used by the tool to define what is noise and what is free space. As you can see, the lower the signal, the higher the noise. Let's say this is a reasonable threshold. And then you have display specific band in color that are the illegal exclusion we named before in the project, correct?
Got it, yeah.
So assuming 75 dBns negative is correct, we just click on calculate, and then the tool will suggest us whether we want to update with the most recent spectrum activity or the one we had when we started the project. Let's refresh with whatever we have right now. It has been able to coordinate the 7 devices and avoid any intermodulation product from EM2, EM5, and EM3. So pretty much all should be optimal and having no intermodulation risks at all. You get on table at the top what channels and specific frequencies each device should be, and then a graphic display of where each guy is being located.
Got it. And can I pinch zoom in if I want to see something? I'm just going to try it. Yeah, there we go. That's, yeah.
Yeah, and you can select, if you go quickly to the display screen, sorry to break you.
Yeah.
We can select which products we want to see on a screen. If it is very crowded, the intermodulation 5, for instance, will be used for calculation, but no longer displayed. So the screen might be easier to look at.
Interesting. So those the kind of white triangles that I see in the middle of the screen that are, it basically looks like a horizontal line. Those are the intermodulation distortion markers.
That is correct. Yes.
Wow. Okay.
As you can see, there are plenty of them because we calculate in our algorithm, we calculate up to intermodulation product 5, and this is exponential. The more devices you try to fit, the higher the number exponentially of intermodulation products. So in some cases, the tool might need to fit some of the microphones into a specific place where some intermodulation product actually fits as well. But it always selects from lower to higher damage and will display on a screen whether they are optimal, as in this case, or non-optimal, or actually failure, because you are actually fitting intermodulation 2, which is considered dangerous.
Mm-hmm, mm-hmm. And I should now, just mention the threshold level setting is very important here.
Yes.
Because as you manipulate the threshold in dBm, that's what's really telling the system what data to throw out. So, as you toggle that threshold up or down, the math gets easier or harder, right? In terms of the number of open frequencies it can locate that are unoccupied based on your threshold, and see mathematically not going to land on an intermod frequency. So that's something you can kind of play around with depending on the results you're getting. But I think just sort of as a general rule of thumb, you want to make sure that threshold is capturing high power static transmitters like DTV stations that you see there. And then whatever other intermittent sources it may have, like it looks like there's some narrowband stuff on the right-hand side there, you would want to make sure that you could capture those as well. But you don't want to bury it in the noise floor too far down, because then the algorithm won't be able to find anything, right?
Exactly.
Yep. So just something to keep in mind is that's a lever you can kind of play with.
And absolutely, good point. And in addition, sorry, Pete.
Go ahead, Ariel.
The additional feature you can use to mix both, Chris, is also exclusion. So if you know that certain area, even is lower than the threshold, might be a problem, just set up a quick exclusion there, and the tool will avoid that no matter what. So both the linear threshold, if you wish, and exclusions are probably the best combination tools for avoiding noise.
And I think it's important to say that this is the release version of this software. And, we talked yesterday about improvements are welcome. And suggestions are welcome. And that leads me to Chad Finlay's question, which is, how easy is it to update this? And, having updated it yesterday for our rehearsal, it's very easy. I mean, if we didn't have all the GAC associated with the network control, it's just sticking a USB thumb drive in it, with the file that you download. So, yeah, it powered on. It saw the drive right away. It did the update itself, and we were off to the races. So I'm excited for it now, and I'm excited that this is a living organism, basically, a living device.
Certainly, our goal is to use the next few months to react to feedbacks and implement first long-hanging fruits, and then more elaborated displays and data manipulation. So some workflows or features that might not be as natural as some of you customers might expect evolve in a way that make it easier and easier to be used. And certainly our uploader system is safe and reasonably easy. You need just a USB drive for that.
Exactly. All right. Well, is there anything else we should look at in frequency coordination? Because I'll move on. I'll have us move on.
Yeah,
Okay. Good.
I think we should just go back to the real-time graph. And so, as you can see on the title, even though we are looking at the spectrum analyzer view, we are combining now real-time data, the coordinated devices on screen, and the threshold position we use at the time to coordinate. So, in addition to calculate and then display which position every wireless device should be, you can monitor real time very easily how that is honoring the evolution of the venue.
It's beautiful. Yeah. I mean, this is exactly what you want, and it gives you a quick view of bogeys that come up, and you can really see whether you're getting other sources of interference that you did not have previously. I suppose one thing I would love to see is if there is an update where we could have multiple thresholds, like split the threshold line into 2 or 3 different, because different parts of the spectrum have different amounts of noise. That would be.
So, kind of a dynamic threshold that is not horizontal, but maybe split into a few scale like steps.
Yeah, that'd be great.
I
And
see.
and yeah, I mean, and Danny Heaton, excuse me, Danny Heaton's comment. Interesting to actually see the intermod. I agree. That was fascinating. To really to really see it. Nor says it's great and beautiful. Thanks to share the knowledge. Thanks a lot. He says.
You're
Or
welcome. Let me point out, Peter, that one of the displays we expect to add before end of year is a channel-only view when you can look at your microphone levels, because of course we located these microphones, but they are not transmitting. We don't have transmitting devices right now. If they are, you are supposed to see a very narrow line there, significantly higher than the noise floor, hopefully. But in a crowded spectrum like this, it might be hard to get this display. So with a single click, we expect to offer a very clean graphic when you will see one microphone per bar with the name and frequency and the actual power level. So in addition to noise and exclusion, you can see how well your wireless devices are performing.
Amazing. And we have Marlon Clark asking, when in the coordination view can you utilize the touch screen capabilities to add or select frequencies? Ariel?
On this screen, on this particular screen, this is fixed by the project. So you can see a start-stop frequency, resolution, bandwidth, everything is fixed. And you need to go back to the configuration project to change things, because that will mean you need to recalculate, and you might need how that impact devices you have already allocated. I think Peter, pointed out yesterday also that it might be useful to have some devices that are locked a particular frequency and never change again, right?
Correct.
So that feature is something that will be reasonably add in for sale future.
And I think what Marlon is asking for is something similar, like in Wireless Designer, which is Electrosonics' coordination software. If I want to change a frequency that it's coordinated, I can touch. I can use my mouse to touch it and drag it across, and it'll update everything in real time. That would be an interesting feature, particularly combined with the fact that I already can see where all the intermods are landing also. So anyways, yeah, Marlon, I
got it. Yeah, that would be certainly a WoW touch screen addition, certainly.
R. Peterson asks, I see it sweeping through the spectrum in this live scan window. Is this different than the real-time spectrum analyzer function, or is this how the RTA works with spectrum sweeps?
by real-time spectrum analyzer, you mean different commercial product, right?
Yeah, I think that's right. Yeah.
Yeah, this is not a real-time spectrum analyzer, which internally will be a SDR, and there are two main reasons for that. First, the speed of a particular real-time spectrum analyzer has a limited bandwidth. It would be like 10, 20 megahertz. And that limited bandwidth is the bandwidth that allows you to demodulate signals. You don't really need demodulation in our typical venue, would provide no information. So the modulating signals is not part of our critical goals. And then the battery consumption of the electronics you need for a real-time spectrum analyzer would mean this tablet will survive barely half an hour on a battery.
And let's talk about power for a minute. It's USB-C in, which is how we're powering it now. I'm actually using a Raspberry Pi power supply, but is it 5 volts that it's looking for? Will it negotiate a higher voltage? What do people need to know?
It's a standard USB. It's documented on the USB port itself. It's USB 5 volts, and it will require any wall-wart charger with 2 amperes. Okay. So it's kind of a 10-watt charger. And while charging, we suggest it to keep it the position you have it, Peter, not horizontal, because it needs to get fresh air on the back to not overheat, because charging takes significant heat. At the time you are using also the CPU at max power. But any charger, and I think Peter is distributing with a USB approved charger as well, right?
Yes. There is one in the box, in the case that it comes with. I just chose not to take it out of its fancy wrap, but yeah, there it is.
So with that charger, you get all you need, and any other USB charger. Now that USB-C is a standard, even across brands that were not friendly to that, I think we can use USB-C for everything.
Yeah, and in addition to the external power, of course, it has an internal battery. And so how much autonomy would I expect on its internal battery?
Using the way we have been, it would be from 3 to 5 hours, depending on how actually full charger was and how many times you put it on hold or actually do a spectrum. So at the time the tool is doing spectrum capture like that, is when taking higher power from the battery, should last 3.5 hours. But if you are configuring saving files that take significantly lower charge, it might be up to 5 hours.
Adam Block, thanks for showing how exclusion works. How about an option to hide the excluded areas from the display? As a Wizicom user, my transmitters are multi-band. Here in the US, there's actually more space between the bands than there is within them. It would be great to not have to see or waste time scanning all that unusable space. Oh, that's an interesting idea.
Yeah,
all right.
We get that requirement from a number of industries, not only wireless audio, because there are many technologies that use fractional bands. So yes, we are expecting to offer at some point in the next few months multi-fractional spectrum that you can configure, let's say, a number of start-stop different frequencies that will display reasonably joined together, merged together, but will be certainly going only where you need it. And for displaying or not displaying things on this screen, you can again go to display and select looking at exclusion noise bands or not. So if you don't want exclusions, they are no longer there.
All right. Yeah. As opposed to just squashing it down and eliminating that, pretending it didn't exist.
Right.
Yeah. Okay. I get it. That's very cool. We still have more features to get through on this. It's I really am amazed. I really do think that Ginsu steak knife. Somebody said, "Can it slice a can?" Which I appreciated that comment. So, I mean, if you're okay, unless I don't want to cut any frequency coordination features off, there's the signal generator aspect of this as well, and I wonder if we can talk about that.
Yes, you can use, going back to spectrum analyzer mode, you can use the generator as a separate tool. So you get kind of a signal generator only device if you need to generate signal that can be captured or used for any particular purpose. But the more powerful way to use that is on the tracking, which use the spectrum analyzer combined with the signal generator together to check your cables, filters, or even antennas to see how they perform. I don't think we have the time or the setup to actually test this, but the user manual on a screen that you can actually, I will just open it for the QR code for the audience to open it if they want to. You can get very specific details, step-by-step information of how to do that.
I just want to show, because I did grab, and I agree, we would be here all night for you, Ariel, if we went through it. But basically, these kind of SMA to BNC jumpers.
Okay.
And I have, a turnaround, and I have a terminator. But yeah, basically, if we look at these. So here's the generator, and yeah, I mean you would put a device under test, whether it's a filter or even just a cable that you want to sweep, or even maybe an antenna that you want to check. Yeah, I mean it's an incredibly powerful tool, and I.
So Peter,
yeah.
Most people in the audio world don't know a lot about this.
I'll say I'm sorry to cut you off, but I will say I was one of them when I started. I would check my coax cables with a continuity meter.
Yeah.
Which is
so what I'm very interested in doing here, because this tool is so, inherently visual, right? We're going to put together a lot of training videos and like walkthroughs, and like there'll be a whole library of content around this for how to check your coax cables, how to interrogate a bandpass filter, how to sweep an antenna to understand how it performs, and like just make it like very obvious, right? Because this part of spectrum analysis and testing RF devices has kind of been more in the RF engineering sort of world than it could be in the audio chain. Because if you can look at the output on your antenna distro, or you can tap off of some part of your system and see exactly what's going on, that could be a really powerful capability. And when you're fine-tuning systems and optimizing systems, this is where you can make huge gains, right? Improving or swapping out a bad cable, or you've got some component in your system that's all bent and kinked and is dumping signal. Those are all really important things to know about. And then for something like bandpass filters, which we're huge proponents of, working with the spectrum you have and then fine-tuning your system using these add-on pieces like bandpass filters to reduce noise and interference, having the ability to sweep those and then kind of map that against what you're seeing on the spectrum analysis side, you're so further along in understanding the operating environment and how to make your gear work better than you were before. So stay tuned. A lot more to come on signal generation school for RF.
Absolutely, and the exciting thing is that it's built into this device. I mean, it's
right.
It's there for when you're ready to use it. It's right there. All right, and then also moving on, We're still not done yet because we should talk about Wi-Fi and 2.4 and 5.8 gig and what that looks like. So Ariel, if you don't mind, I'm gonna swap antennas.
Please.
And here we go. So it comes in the package. You get both of these antennas. This is pretty typical for UHF VHF ish. And then this is the Wi-Fi antenna that it comes with. And here we go. So if I'm experiencing some kind of issue or what I see online all the time and what I've had happen is another department comes to our department and says, hey, your peanut butter is in our chocolate in 2.4 gig. What's going on? How can this device help answer that question?
Right. You would click on the Wi-Fi analyzer mode, right? Select with that antenna fit on the spectrum analyzer which technology you want to check, and then you will get on screen what's the exact activity you have on that band. One important note is this, as an spectrum analyzer, this is not actually understanding about particular SSI channels. It doesn't actually know if one router or the other is transmitting a particular channel. It actually detects all the RF activity and display it per channels, so you know what kind of power you are trying to deal with in that particular channel. It might help you to select a different channel for your router and then have all your client devices automatically connected to it, or to identify something that normal Wi-Fi tools will not, because they only see Wi-Fi channels. They don't see other RF activity. So that for 2.4 or 5 gigahertz, this will be a good example of what been asked before. Actually, 5.8 gigahertz for the trying eye is actually a split spectrum, has a big empty space in the middle, and we depict all them together, even though they are not. And that's the way we expect to provide fractional spectrum in one screen at some point, future upgrade for a spectrum analyzer as well. So you can get all the information on a screen reasonably larger than you would get on a cell phone or a standard information. As you can see here, there are a few channels that are very clearly using significant power levels.
Yes.
I agree. I agree with that, Ariel. This tool, in combination with any of the million apps there are for your phone or your laptop that will just sweep your Wi-Fi radio in your phone or in your computer to tell you what network is what the general signal level is. That plus this, I think, is the complete picture of what's going on in those two bands in a given location. And one thing that we run into a lot are people setting up dedicated networks for digital mixing consoles. Wi-Fi is in everything now in pro audio, stage boxes, lighting effect systems. I mean, it's the list gets pretty long, monitoring software. And so I think when you're gearing up at a location, understanding what the Wi-Fi sort of footprint looks like is a good step, is a good sort of check on the totality of the RF, going on in that space. Now, this won't be able to tell you, oh, that's this network, but you can easily get that information off of a lot of different apps. But if you have a strong source, you can find it, just by walking around or using like a directional antenna to try to understand where given channels are where those radios are located.
Absolutely. And I have on my Android phone. I won't find it now, but it's a Wi-Fi analyzer. It gives me detailed information about the SSIDs. That's helpful, but in some ways, if I'm on set and I'm looking for where to put my ZaxNet, or even any of the 2.4 gig back channel controls that I can select a channel, this is super helpful.
Yeah.
And even if camera comes to me and says, "Hey, our wireless focus is having interference," I can probably see it. Number one, and number two, sort of direct them to a clear place. And I think again, this is the first version of this. Like Ariel yesterday, we talked about the possibility of more detailed, finer channels in 2.4 gig to match the Zigbee channelization, that kind of thing. Part of why I'm excited about doing this live stream is to get the conversation going, so we can really see what's useful to people. Incredibly powerful, and just a information that is actionable is really what we need on set. I think we're sort of coming to an end here. I'm just going to make a call out for any last minute questions or comments or suggestions.
One quick comment as well is this additional mode that is waterfall. It might add a new dimension of information you might need, or might you be find it useful sometimes, because as opposed to the Moviola, going back and forth in time, that you always see one single spectrum, you can see on one single screen what's the historical evolution of your spectrum, either in 3D or in 2D. So
wow.
In many cases, when there are pulses or signals interference that are coming and going, and might be hard to look at the particular time this happened, this view is usually the best tool you have at hand to locate that particular incident.
And here's where you find all your two-way radio.
Yeah, that's right, because you'll see them as little hotspots that pop on and off as they key the radio.
Yep.
All right. Well, look, I think if there's nothing else, I think we'll leave it. We'll leave it here. I cannot thank you enough, guys, for sharing this, and thanks everybody for watching. Keep those questions coming. Ariel and Chris will see them even as you watch this in replay. Ariel, we'll say goodnight to you in Spain. Thank you so much.
Thank you for the opportunity and your time.
Thank you. And Chris, great to see you as always. I'll see you on the trail real soon, I hope.
Yeah, man. Sounds great. Great to be with you all. Thank you so much.
Eric, just before we sign off, I see this last minute question. Could future updates include SSID on the Wi-Fi? That sounds like a different device, like we were talking about.
It might be actually available either with some of the internal features we have disabled right now for 2.4 gigahertz, but we might also use an external USB dongle to offer that if there's enough demand for it. So the device is capable, and the opportunity is there. We will see if we can offer that. It won't be in the short term, sorry.
Amazing. Thank you. Thank you, guys. We'll see you. Stay on the Zoom call while we sign off. Thanks, everybody, for watching. Thanks to our crew. Thank you, Jared in Brooklyn. We'll see everybody. Have a good night. Good day.